Okay, so basically today discuss about the some Python for geospatial analysis, how we can easily use the different types of Python library. Okay, suppose for the drone imagery, we can easily access by through the Python library raster. So we'll discuss about that, how we can easily use the different types of Python library, and then how we can easily work with different types of agriculture precision area. Okay, so okay, let me share my screen. Okay, can you see my screen?
Yes.
Okay, so previous day I also show you some analysis using Google Colab, but we face some problem. Okay, so sometime it
Yes.
show the problem is crashed. Okay, automatically crashed, and we don't get the result. So for that, we can also use the another way. Suppose in this time our Google Colab have some limited GPU or CPU, but when you use your own computer, suppose you can simply buy a high range of GPU or CPU laptop or computer. So for the you can easily run your model from your local storage, from your local computer. So then it will be very effectively work, because we can easily buy and then we can easily use it, okay, for our using our local computer. So for that I also show you that how we can easily work with our local computer for the different types of Python library. So it's very easy way. So first of all, you need to download a software. It's called the Anaconda distribution. Okay, Anaconda distribution. Anaconda. So I simply search Anaconda, or you can see this the website anaconda.org. So this tool you need to download. First of all, you simply download this Anaconda distribution. So basically you can see it's the standard Python package to the world. So lot of Python package we can easily work with the Anaconda distribution. So our 120 million package request every day they take from the Anaconda distribution, and we can easily installation of package from the Conda 4G or Bioconda, PyTorch and more. Okay, so for registration you can simply put your user name, then email, then password, and then simply registration for free. Okay, so after that you can download, you can simply download the Anaconda also, okay, without registration, not need registration, it's optional. So you can see the download, open source, user friendly and trusted. So from here we can easily download, you can see the free download. Okay, just click on here. And I download suppose open source or get start today. Okay, so I think they are also changed their downloading system. So first of all, in registration. Okay, so after registration you try to download. Okay, so here I already downloaded. So you first of all you try to simply download the Anaconda distribution and install in your system. So in my system I already installed it. If you check my system, here I already installed the Anaconda distribution. So this is my Anaconda distribution, you can see. Okay, so after installing, simply open the Anaconda distribution, and we can easily work with different types of environment we can easily create. So after downloading the Anaconda distribution, further we simply work with a lot of Python packages we can easily integrate and work with that.
Ah,
Yeah, please.
okay. Okay. Yes, I want to remove that the pop-up window.
Mm.
The small pop-up window. Yes.
It's opening. Okay, so you can see we find out this type of interface of Anaconda distribution. So in the Anaconda distribution, if you check the environment, we find out this type of environment. So first of all, this is the base or root. Okay, so it also available when you install first time. But further, we also create different types of environment for our different type of purpose. So here you can see I create the two environment and I put the name GeoAI and also put the another suppose Python Geospatial. Okay, and create the environment. So if you want, you can also create the environment from here. You can see just click on the create and put the name. Suppose I put the name is that suppose new AI. Okay, and I simply save, and I want to create the environment for the Python. Okay, so this is my Python version. It automatically show you in here. So or if you want, you can also create the R, but now we talk about the Python. So I simply check mark the Python and then create. So now you can see it create the new AI. I just put the Python environment. I create the environment. So this is the one way we can create the environment, and in this environment we can install all of our packages, all of our Python packages. Okay, so now you can see it creating the environment. It creating the environment.
When you are creating the environment, you must be online, is it?
Okay, so for the installation different types of package, when you install the package and create the environment, then you need to connect the online. Otherwise we can also run this type of package without online, no problem. Okay, so first time for installing the packages. Okay, so you can see find out it create the new AI. This is my environment. So in this environment we can install it the different types of package. Okay, different types of package for the geospatial analysis. For we can easily geopandas or raster. So different types of Python package or earth engine platform. So different type of thing we can simply create. Okay, so this is the one way to create the environment, or if you want you can also put the another way. Suppose you can simply click on the terminal. Okay, simply find out the CMD or terminal on your computer. So from the terminal, suppose I want to use it and create the environment. So for that, simply write here suppose conda. After installing the conda distribution, simply write the conda and put the create. Okay, so conda create, then put the this symbol and put the name. Okay, and put the your environment name. Okay, suppose I put the name is that suppose I put the geospatial. Okay, I put the environment in the geospatial. So now if I just click on the enter, so now this environment is create. You can see it show the proceed yes or no. So I want to create, so put the Y and enter. So now it create the environment. You can see it create the environment. Okay, and if you check the environment is created or not, so you can easily find out the another environment it created. You can see find out the geospatial. Okay, but previous time it was not. Okay, so this is the two way when you create the environment. You can write the command using your terminal, or if you want you can simply create the environment from here. Okay, just click on the create and create your environment. So basically it also better, so you create the different environment for your different project, so then we can easily handle. Okay, suppose I just create the one environment for the only for the drone image analysis or geo AI or Python geospatial analysis, so we can create the different environment for our different project, so then it will be more effectively. Okay, so in this case suppose I create this type of environment. So this is the my one in geospatial environment, and this is my another new AI environment we can easily create. So there is the two way for creating the environment. One way we can simply click on here and simply work with that, and another way simply write the terminal. Okay, just simply write the code conda create, then put the name and put the your environment name, so then it will be create. Okay, suppose I want to remove the environment, so how I can remove? So simply click on this environment and you can see the remove option also in here. Just click on the remove, so now this environment is removed. Okay,
Yes.
so after removing, suppose I want to work with this geospatial, this environment I want to work. So you can see here I already open, I already create. So now you can see after creating the environment, it show me that to active this environment, suppose I want to active this environment. So because I have lot of environment I already create, but I want to active this environment and work with that geospatial. So for that, simply write here conda activate. Okay, conda activate, and put the your, you can see it's your environment name geospatial. So simply put here the geospatial. Okay, and then press the enter. So now if you check, we find out that it's for the geospatial. Okay, so now your geospatial environment is opening, and I want to install the different types of packages. Okay, I want to install the different types of packages. Suppose I want to install geopandas. Okay, this is one kind of Python package. We can easily handle the shapefile or others. Okay, so I want to install the geopandas. So for that, simply put here the conda install then put here the channel conda 4G, and put the geopandas. This is my Python package name. And now if I just click on the enter, so now it just installing the geopandas. And you need to install only for the first time. Okay, other times you don't need the install process. Just simply open your code editor and you can easily work, because in this time we are just use our local computer. Okay, locally we run our model. So that's why previous time we already worked the Google Colab. So we need to install the again and again different types of packages. Okay, so but in this time you don't need the installing this type of package, just only for the one time. Simply install and then it will work. So you can see, find out this type of other library. Okay, you can see the following new package will be installed. So geopandas is also available, this type of other package. You can see the folium, also you can see different types of library. So I want to install all of package with geopandas, so just put the Y and enter. So now it will be installed all of packages related to the geopandas or pandas. You can see pandas is also cover pandas, or you can the pros. So different types, you can say sci-fi, scikit-learn. Okay, different types of library is also installed with the package of geopandas. So now you can see it show the done. Okay, you can see done. It means that geopandas is successfully installed, okay, in your system. Okay, it's successfully installed in your system. So now how I can understand it's successfully installed or not? So for that, if you want, you can simply open the Python. So I simply call the Python and I want to import. So Python C and then import the geopandas. So simply put here the import and put here the package name geopandas and then enter. So now if there is no problem, you can see if there is successfully executed, it means that your package is successfully installed. Okay, it also loading, you can see. So it's only for the checking, but there the another way we can check. There is no problem because I find out that done, you can see preparing, then verifying and executing is the done. So it means that your package is successfully installed. All of package is successfully installed in your system. And what is your environment? Your environment name is the geospatial. We put the name is the geospatial. So this package is installed in your geospatial environment. Okay, you can see it also imported. There is no problem. Okay, it is successfully imported. It means that your package is successfully installed. So I want to install it the other package also. Suppose I want to install it the raster matplotlib. Okay, so for that, simply put here the conda. Again, put the install and install it. Suppose I want to install it channel conda 4G and then put your package name. Suppose I want to install a GEmap package. Okay, so GEmap package we can easily use to working with Google Earth Engine. So I installed the GEmap package then install it. Suppose I want to install it for raster. Then I want to install it. Suppose I want to install it for another package. Suppose geopy. Okay, this is another Python package. Then suppose I want to install it that matplot library, matplotlib. Okay, as well as we can also any package. So further, if you need any other package, you can simply push the same approach and install it. So suppose I want to install this type of package. And finally I want to also another package. It's called the Jupyter Lab. So Jupyter Lab, okay, and then press the enter. So now all of package is successfully installed, and first time it take the permission yes or no, then put the Y and press the enter again. So now I can see it show a problem. This problem is that are not available from the current channel matplot library. Oh, sorry, we put the mistake spelling. Okay, just run my again. So just I copy, and then just paste here again. It will be matplotlib. Okay, so I put the wrong spelling in here. So it will be matplot plot matplot plot matplotlib. Okay, so now enter again. Then press the Y and enter. So now this type of package is installed in your system. Okay, so now you can simply find out the done. So now if you want, you can simply suppose open your Jupyter Lab. So simply put here the Jupyter Lab. Okay, simply write it and then enter. So now it directly open your code editor in the Jupyter notebook. We can easily find out. Okay, you can say it's open. Okay, yeah, please.
Please, I can rejoin again. I can leave and then I can rejoin. I don't see.
Okay, just try. Okay, please.
Sorry.
Now can you see my screen?
Yes, now I can see now.
Okay, so let's go. Yeah, so here you can see. So I also discuss further later about this type of things, no problem. So we can easily work this type of things. All right, so I'm run the code in here. Suppose I want to import some package. Suppose I want to import one package. Suppose geo pandas. Okay, suppose I want to import.
So sorry, sir.
Yeah, please.
So the packages that I imported using this Jupyter notebook must be installed first from the Anaconda.
Yes, only for the first time.
For the first time, is it?
Yes, only for the first time. Okay, suppose okay. Let me.
If I didn't install,
yeah.
If I didn't install such a package for the first time and I want to import, will it be imported or will it not?
Okay, so only for the first time you need to install. Okay, and so I already installed, you can see in my terminal. So I already installed all of packages. Okay, only for the first time.
Yes.
Suppose now I just simply remove. Suppose I just open show you again for the first time. Suppose I just simply remove. Okay, just click on here, just remove my terminal, and also remove my Jupyter notebook. I also remove from here. So now I want to work without install. So for that, simply open your terminal again. So in the terminal, it show the base. You can see it show the base, but I want to active my environment. Okay, so I create the environment. What is my environment name? Geospatial, because in this environment I already install it, my all of package which I need. Okay, I already install it. So now I want to connect this geospatial package. So how I can connect? So for that, simply open the terminal and right here conda activate activate conda activate, then put your environment name. Suppose I do involve
Okay.
GeoAI. So which environment you want to work? Simply open. So I want to work, suppose GeoAI. So this is my previous, I already installed all of my necessary package. So I want to open it. So just put at the GeoAI. So this GeoAI, this environment, I already installed all of my Python package which I need for my different types of AI related work for the geospatial. Okay, so I simply just press
Yeah.
enter. You can see now it show the GeoAI. Okay, so now I just active this environment and I want to open my Jupyter notebook. If you want, you can also open the Jupyter notebook in a specific folder. Suppose if you check in my folder, from my folder, suppose from my download folder, you can see from the download folder, we find out some suppose this one, so I want to open this one. Not, so I want to open this notebook. Okay, so I want to open this notebook. So this is one kind of notebook. So here I already write some code. So I want to open this notebook. So how I can open? So it's very easy. So for that, simply open the terminal and active your GeoAI package. Then put the CD. Okay, CD, and then press the tab. Then we can find out all of folder name. Okay, all of folder. So from the folder, I go to the download. I go to the downloads. So simply put here the DOW and press the tab. It show the downloads. Then press the enter. So now I just entered the download folder. You can see it show the downloads. So in the downloads folder, I will then I simply can see in my download folder. This is my download folder. So from the download folder, I want to go this folder. So corn yield prediction. So this is my folder name. I want to go. So how I can open it? So for that, simply put the CD again, and then corn. This is my folder name. So put here the COR, then press tab. Automatically come the folder name. Okay, then press the enter. So now you can see it show the corn yield field. So now I just simply access all of file, but I want to go to the more. I want to go this file. Okay, so I want to enter this folder and then open this file. Open this file. So for that same process, we simply put the folder name. So this folder name I put at the CD. Folder name is that CLE. Then press the tab. So you can see automatically come and then enter. So in this folder, I want to open this file. Okay, in my Jupyter Lab, I want to open this file in my Jupyter Lab. So how I can open? So for that, simply right here, Jupyter Lab, and then write the file name ml, then press tab, automatically come and press the enter. So now this notebook is automatically just open. Okay, it automatically open. You can see it opening. Yeah, so now I can see it opening. So now we can simply work with this notebook and also complete our analysis easily. Okay, or if you want, you can create the new notebook. So how I can create the new notebook for this folder? So again, I will show you that. Suppose I want to create the new notebook. I am not working the previous notebook. I want to create the new notebook. So how we can easily create the new notebook? So for that same process, just open the terminal and put the conda. Just active your conda activate. Suppose I want to activate this conda GOAI. So write this GOAI. So this environment I already installed all of my necessary packages which I need. Okay, so just active. So now I want to create the new notebook, okay, in a specific folder. Suppose just put the cd and I want to just put the cd and put the tab. So I want to create the folder new notebook in my download folder. Okay, in the download folder I want to create the new notebook. So for that, simply put here go to the download folder and now simply open Jupyter Lab. Okay, Jupyter Lab, simply write and then open. So now in this folder it create the new notebook. So first we set the notebook name, just click the enter. So now you can see it open the new notebook, and this new notebook is open in our download folder. You can see in the download folder. So just click on the, you can see Python 3, just click on here. So now you can see it will be work. Okay, this is my new notebook. So further simply you can put the rename and put the name, suppose it's your suppose first practice. Okay, so now this is the way we can simply create the new notebook, as well as we can also open our previous notebook. Suppose I already work, so now I want to add the more work on my code, or previous code I want to open, then simply apply the previous work. Okay, then it will work. So now I want to import, suppose I want to import some package. Suppose import GeoPandas. I want to import GeoPy. I want to import, suppose, GEmap. Okay, so I want to import raster. Okay, or import matplotlib.py plot as PLT. So basically this is the short form. Suppose I put the rasterio as RIO short form. GMap I do not need. GeoPandas as suppose GPD. Okay, so just I put the short name. So when I need this package I simply use the GPD. When I need the package I simply use here the RIO. When I need this package then I simply use here that your PLT. So now run. So you can see now it's working. It's done. There is no problem. It means that your code is successfully worked. Okay, your installation process is successfully done, and you not need to install again and again. Okay, like as Google Colab. So we already know about the Google Colab. We need to install again and again GEmap or rasterio, this type of package. So now I want to connect the Google Earth Engine in my code editor. So how we can connect? So for that, simply connect. Just put here ee dot authenticate and then run. Oh sorry, we also need to, for the Earth Engine we need to import another library. It's called the import Earth Engine. Okay, so simply run. So now authenticate. So true, there is no problem. So first time it just simply connect with yours, it's show you the link. So simply click on the link and simply connect. Okay, so I already do it, so that's why it show that true, there is no problem. So I take the new cell and apply ee dot initialize. Initialization and put here project name. So put the project. So for my case, my project name is ee dot Mizan 690. So this is my project name, cloud project name. Just I entered. So it also done, there is no problem. Okay, so now I can easily work any data set from Google Earth Engine. Okay, and also integrate this type of packages. Okay, so there's a lot of, you already know about the Google Earth Engine. You can easily work, create the different types of map, different types of analysis, because we can easily integrate the Google Earth Engine and we can easily get the lot of satellite images, lot of data set, lot of analysis we can easily do using the Google Earth Engine. Okay, suppose I just simply call a data, I show the one example because you already know about the Google Earth Engine.
Please.
Please.
If I use exclamation mark and put the word install, and I mention the specific package, will it be installed?
Not need again install. So install is done. Okay, install is not need in the Python, because you can see here we already installed all of package. Okay,
if I want new package which I have not installed yet,
then need to install again. Just simply active the conda, active your environment and install. Okay, simply active and then install on your environment.
Because I remember in the Google Lab we were using the pip install.
Yes.
So my question, if we use the pip install in this Jupyter notebook, will it function or not?
Not need, because we just install from our terminal. Simply we can install the conda 4G. Okay, same process, and then we simply install again. Okay, suppose here some package, new package which I don't install, so I need to install again. So for that, simply active your environment, simply active conda active, put your environment, then simply install it. Okay, then simply import, not need to pip, it's not need in here. Okay, all right, so now suppose I want to import a shapefile. Okay, so in my asset, suppose I simply take the US data set. I take the large scale national boundary polygon. So this data set I want to use in my Python. Just I copy and then connect with my Python. Okay, just I run. Okay, so now I simply filter my country. Suppose I take the variable AOI, okay, and call the table. Okay, I want to filter it. So same like as Google Earth Engine code. So Earth Engine dot filter, that equal what. So put here country name. Put the country name. Suppose I put the name as Bangladesh. So now run the code. So now this variable stored the Bangladesh country shapefile. So I want to display the map in my Bangladesh boundary shapefile. So further, how I can display? So further, we simply help of GE map package. Okay, so just take a variable. Suppose GE map package. From the package, I simply call the map function and run. Again, there is no problem. So I want to display this map. So just I put here map.add layer and put the variable name AOI. Okay, and then this variable map I simply copy and show and run the code. And as well as I want to focus on the center of my given shapefile. So for that, we already know map dot center object is AOI, zoom level suppose 10, and run the code. So I can get the bound shapefile. So now I am not discuss about the Google Earth Engine. So you also try, because we already know about the Google Earth Engine, how we can easily work the different types of data. But this is the way we can easily connecting the Google Earth Engine with our Python environment. You help of Jupyter notebook. Okay, help of Jupyter notebook. So in this case, GE map or Earth Engine. So this type of package, we simply install it in our environment. So that's why when using this type of things, you not need to install again and again. Even you can see authenticate just need only for the one time. Okay, I already run the code in my Jupyter notebook, so that's why you can say show the true, because I already complete the authorization I already done from my Google Earth engine and with the Jupyter notebook, and you can see I already done the, so that's why it not take much time for installing, or also take the much time for the your installation process, or authentication or initialization. It's not need much time, so we can easily work with the any kinds of Google Earth engine dataset and also integrate with the Python. Right?
And if I want to start to use the shapefile which is installed in my in Google Earth Engine, the shapefile which is in my computer, the same process.
Yes. So for, okay, no. In this time, suppose I have a shape file in my computer. So how I can work with that? Okay, I'll also discuss about that. How we can work. Suppose I have some satellite image or drone imagery. So how I can handle?
Yes.
So this thing I will discuss
Yes.
about that. So basically for that we are just use help of GeoPandas. Okay, GeoPandas. So GeoPandas mainly it they extend the Python pandas library to enable a special operation. Okay, so we can easily work with special operation for our reading the shape file or others. So we can easily do it, as well as we can easily read the shape file or filter the shape file. Different types of thing we can easily do using the GeoPandas library. Okay, so for that we need the GeoPandas. Suppose when I work with the raster, different types of shape satellite imagery or different types of TIFF format, then we need the rasterio package. So let's go ahead and discuss one by one. Suppose I have a tip image. Okay, this tip image I want to read in here. Suppose I have a drone imagery. So this drone imagery I want to read. So for that, you can simply take the new cell and put the variable name, suppose path. I put the variable name as path image img equal. So now simply call your image. So where you stored the image. Suppose I want to display this image. So this, suppose I want to display this tip image I want to display. So just simply click on here and you can see the copy path. Okay, just copy this path. Okay, but previous time we already show when Google Colab this type of image we need to upload again, but in this time don't need upload in the Google Colab, because I can easily connect my dataset. I can easily connect my dataset with the Jupyter Lab or Jupyter Notebook easily. So simply put here the, because I simply put this is my path. Okay, then run it. So now I want to open this image and display the image. So for that we need to help of rasterio package. Okay, so just put the width. I want to open with rasterio. So put the rasterio. This is the Python package, and apply the open function. Open this path. Just like copy and paste. Okay, and then put here as src and define the image. I want to image, take the variable src dot read. Go ahead. So now run the command and check what happened. Okay, it's a problem. Rasterio. Okay, sorry. We put the short name. Okay, rio. So just I put this short name. Okay, because I already put the short name. So now I put here the rio dot open and run the code. So now I hope there is no problem. It's loading.
Sir,
Yeah, please.
what SRC means?
So okay, so in this time you can see this full line, we simply put the short form as src. Okay, so
Okay, okay,
this
okay.
full line I
Yes.
simply put the short name src. So further I simply call the src and read the information. Okay, same like as you can see the as rio as gpd.
So I can put in any name.
Yeah, any name. Okay, it's not the fix, we can put any name, no problem.
Oh, I understand.
Yeah, so now after read the information there is no problem. So if you want, you can simply take another variable. Suppose just take the new cell and put the img and run it. So now you can see we can get the information. Okay, all of how much band. So there are mainly 4 band. Okay, as well as how much x and y. Okay, we find out this type of information for this image. So I want to display. So I read the information. So I want to display all of bands. So I take a variable img and then call the img and read the band. Okay, so for that put the sequence 0 to 3 because there are 4 band, 0 1 2 3, total 4 band, 0 to 3. So now run the code again. So now we access only for the 0 to 3 bands, so we simply define the bands. Okay, just a minute. Okay, so we find out this type of, suppose I want to check the image shape, I want to check. Okay, so for that simply put the image and put here the shape function and then run. Okay, tuple object is not the callable. Okay, just a minute. Image shape. So we find out the image shape, we can see. Okay, so we find out this is the total first 3 band, commonly red, green and blue we find out, and also show the height and width, okay, of the image, total height and width, total shape we find out, height and width. So now we apply the another function, it's called the transpose. Okay, so if you check, just I put here the image and apply a function, this function called image equal, I put the image and apply the tran SPOSE, okay, transpose. So this function, what happened? So when I put the transpose, so in this time we can see, first time we find out the band, then we find out the height, then we find out the width. Okay, but when I put the transpose, suppose I put the transpose is that 1 2 and 0. Okay, I put the transpose 0 1 2 0. So it means that, so this is my image shape. So first time I find out, if you check the shape, we find out the first one is the band. Okay, bands. Then we find out that it's a height. Then we find out the width. Okay, so this is my real shape of the image. So bands, then height, then width we find out. Okay, so when I after apply the transpose, then what happened? So when I apply the then it will be happen, suppose height, width and bands. Okay, height, width and bands. Suppose when I apply the transpose 1 2, so this is, they can see 0. Okay, this is the 0, this is the 1, this is the 2. Okay, so I make the combination 1 2 0. Okay, so first time bands, this is the 0, then 1, then 2. So I just transpose 1 2 0. So 1 2 0, what means that when I apply the 1 2 0, so it means that it stored the information. First of all, it show the height, then width, then 3. Okay, 3, mainly 3 bands. So in this case, you can say I simply make the transpose. Transpose I means you can see 3. So last serial I put the band. First height and width. I put the last serial is the band serial. So bands height and width. So I put the 1 2 0. It means that 1 is that height, 2 is the width, and this serial is the 0. So 0, this third number step indicating about the band information. Okay, third number step indicating about the band information. Okay, so I simply transpose. So just run the code again. There is no problem. And now if you check the image shape, you can see, just simply check the image shape. So now we find out that this shape, okay, first time we find out the height, then width, and then we find out the band position. So transpose is one kind of function. It basically help you to standard format for visualization of your image. So we set the position. In the third position we set the band information. First and second we simply set the height and width. So now you can see we find out this is the height, then width, and we find out the band information. Okay, so it's very important to display the imagery. So when you work with that, so select the first 3 events and we just apply the transpose to convert the sequence. Suppose height, width, and bands. So now we try to display the image. Okay, so let's try to display. So just I simply suppose I put here the plot. I already put the plt plot dot im show, and I will show the image for im the image, and put here the plot dot show function and run it. It's loading.
Done. It is done, sir.
So now you find out this type of imagery. If you want, you can also put the figure size or increase the figure size. Suppose I put here that plt image show. I increase the plot figure. So we put plot and put here the figure and define the fixed size. Fixed size equal suppose 14, 8. Or you can also increase the range, no problem. You can find out this type of image. So now how I can display the shapefile. Okay, so let's go how we can display the shapefile. So for displaying the shapefile, we need to help of GeoPandas library. Okay, so for that, simply take the new cell and take a variable, suppose AOI path, and then further which shapefile. So here I already have shapefile. You can see. Suppose I am to work with this shapefile. So I want to display this shapefile SSP. Just simply copy the path, okay, and then paste here. So now it will be stored in the shapefile. So run it. So now I want to display the shapefile. So how I can display? So just take a variable. Suppose gdf equal. I call my package name. So this is my package GPD. Okay, GeoPandas package. So I want to display it, and then simply put the read file function, and then simply read this file. Okay, so now run the code and take the new cell. So now we define, just simply create a plot. Okay, so first of all we simply define the figure size, put at that fig figure size, and take the ax. So I take the two variable fig and ax, and I stored the information from plt. I create the subplots. So put the sub plots. Okay, and then I define the fig size. So I put here the fig fig size equal. I define the fig size, that was 10, 10. Okay, and then I want to add the plot. So just I call the gdf. Basically this variable is stored the path. So gdf dot apply the boundary dot plot function, and ax equal ax. Okay, just this variable ax equal to ax, and run the code. So we find out this type of boundary or shapefile. Suppose I want to change the color. I want to change the color of this type of color. Okay, it shows this type of blue color. I want to put the another color. So for that, just put here the s color equal. I put suppose YOLO and run it. What's the problem? EDGCOLOR. Oh, we need to put the comma sign with the comma. So you can see, find out this type of red color or any color. You can simply mention the border. Suppose I put the red, find the red color. So this is the way we can easily use, as well as you can also filter the shapefile using the GeoPandas. Okay. Okay, so you can easily download the satellite imagery. Suppose you can simply download the satellite image from Google Earth Engine and then store it in your local drive. And further, you can also work with the raster or GeoPandas. This type of library you can simply use, and it can also work. Okay, so this is the benefit to use the Python. Okay, so you can easily integrate different types of Python library easily okay, and integrate with the Earth Engine, Raster, GeoPandas, and a lot of analysis very quickly you can easily do. Okay. Okay, so now we try to work with the, suppose this is my boundary. So in this boundary, we try to get the bounding box of our vector layer. Okay, suppose I simply create the bounding box of our vector layer. So we define the bounding box of your geodata frame. So this is my I created geodata frame, and further we simply define the suppose longitude, latitude, this type of information, and we simply define the cell size. So let's go through the practical example. Suppose I create some bounding box. Okay. So for that, take the new cell, and for creating the bounding box, we simply define, suppose I take a variable, suppose x mean, take the another variable, suppose y mean, take the another variable, suppose x max, take the another variable, suppose y max, okay, equal. So now we define the x mean, y mean, x max, y max. We simply set equal to this shapefile. It is stored in the GDF. Just like copy, and then I simply put here the total bounds function. Total bounds function. So now GDF total bounds function, it return the bounding box of your geometry data frame. Okay, basically this geometry data frame, it return the bounding box. Okay, so now you can special extent of your data. So now simply check and run it. Okay, it show the geometry data frame has no attribute total bounds. Okay, so this is the total bounds. Okay, this function. So now check again. Okay, it also works. So now we try to check the total x mean, y mean, x max, y max. We try to check it. So you can find out. This is the x mean value. This is the y mean, x max, y max. Okay. So basically, it show the result for bounding box area. We find out. Okay. So now we define the cell size. Okay. Suppose I take a variable. I put the cell size for x. I put suppose 25. Okay, for the x direction. So suppose I put the cell size x equal to 25. It means that each grid cell will be 25 units wide in the x direction. Okay, in the x direction, this is the x and this is the y. So when I put the cell size equal to 25, what does mean? It means that in the x direction, each grid cell will be 25 wide in the x direction. Suppose I define the y direction. So put here cell size. I define y equal. Suppose I put the 12. So what this means that? It means that this means each grid cell will be 12 units high in the y direction. Okay, and x direction we find out the 25 each cell. So simply you can also increase or decreasing the value. So in this case, suppose each cell for the x direction 25 wide in the x direction and 12 wides in the y direction. Okay. So now we try to create the nested loop, create the grid cell nested loop, and then we display the result. Okay, so we try to create the grid cell nested loop. To run it. So I put a variable, suppose grid cells. I put the blank, and then I create a loop. Okay, so I put the for creating the loop for x0 in np. np basically numpy. We also need the numpy. Okay, let me check. Okay, let me also import the numpy. So import numpy library as a np. So we can also use it. Yes, please.
Let's go on. Nothing.
Which one?
No, nothing. Let's go on.
Okay, any question, please?
No problem.
Okay.
Continue. Sir.
Okay.
No problem.
So just I simply call the numpy library and then put the arrange function. Arrange. I call the xmin. I already defined what is the xmin. This is my xmin, comma. Then x max plus cell size x. So I copy and paste. Just copy and paste. Okay, and comma, I put here the cell size x again. Okay, so now create the another loop. So basically this will create the two loop, so that's why it's called the nested loop. So create grid cell using the nested loop and take the another one. Suppose for I put suppose y0 in np dot same arrange and define y min, comma, I call the y max plus call the cell size y. Just copy and paste here. Okay. And apply, put here the cell size y. So I create the two nested loop and I define the boundary or define the bounds. So for that, I put here suppose x1, take a variable x1 equal, call the x0 minus cell size x and paste, and take the another y1 equal, call the y0 minus y0 plus cell size y. Okay, so now we simply, so in this case we create the two loops. So outer loop moves the along x-axis from x min to x max. Okay, and inner loop moves along y-axis from y min to yx, y minimum to y maximum. So finally we just simply call the another library, create a rectangle polygon. Okay, so it's called the shapely. So okay, let me import the shapely again. Okay, there is no shapely, so import the shapely. Okay, so now we simply call the shapely library and create the rectangle for each cell. So for that, just I call the grid cells and then put here the append function, appending using the shapely. I call the shapely library and create the geometry rectangle, put the geometry function geometry and define the x0 comma x, so comma y0 comma x1 comma y1. Okay, so now run the code. NumPy has no attribute about the array, so if it's a problem, so the nt.arrays is not available. Okay, let me check for the module NumPy there is no function for arrays. Also, you make the mistake, so this is the singular. And now let's check. Oh, module object is not callable. Let me say we create the loop x0 in NumPy array arrange xmin xmax plus cell size x. Yeah, please. Shapely geometry. Okay. So we put here the geometry. Okay, geometry dot box function because we create the rectangle box. Okay, now let's run again. Okay, so now it's okay. Perfect. Yeah. So shapely, from the shapely we call the geometry and call the box function. Okay, not only for the geo because we create the rectangle box. So now convert this type of convert to geodata frame. Okay, so for that just take the another variable. Suppose I put the variable name is the cell equal. I call our shapefile. So it is stored in this variable gdp or gdp. This variable is stored in our shapefile, and I pressed here. So now we convert geodata frame. So put here the so no, we call the GPD, basically GeoPandas library, GeoPandas, GPD, okay, and apply the function geodata frame. So put here the geodata frame. So now in this time we find out put here the grid cells, and set the columns equal geometry. And also set the coordinate reference system. So we put the cell equal, put the cell, just call this variable name cell dot set CRS, coordinate reference system. So basically I want to add the same CRS which I get from my shapefile. So it's right in the GDF. Just like copy and set. So put here, paste here, and apply the CRS function. Now this cell is the same coordinate reference system with my shapefile. Okay, so now run the code. Okay, there is no problem. Okay. So now finally we simply create the overlay. Suppose I create some cell in the x and y. So just I simply overlay with my boundary. Okay, this is my shapefile. I want to create the overlay. So for overlaying original geometry with the grid, so for that take a variable. Suppose GDF overlay equal. I put suppose GPD. Okay, GPD GeoPandas. I simply call this function and apply the overlay function. Overlay with my shapefile. So this is my shapefile, which is GDF. It's stored in my shapefile, and I also create some cell. Okay, I create the some cell. So I create the overlay shapefile, and which cell I create, I simply make the overlay. So I call the cell. just copy and paste. Okay, so now how I can overlay? So just put here the how. So I want to create the overlay using the intersection. Okay, so it means that keep only the part of the GDF, keep only the parts of the shapefile that intersect with your grid cell. Suppose in this time, if I create the cell, so it also shows upon from my boundary, it also creates some other x and y cell, but I need the cell only for my boundary, not need the outside of my boundary. So further we simply put the how, put the intersection. So put here the intersection, just type it. So now run it. Okay, so everything is okay, there is no problem. So now I want to plot and check the result which I get from the cell. So for that, just create the take the new cell, and I want to create the figure, and now also take the variable suppose ax, and I plot, call the plt plot, and also put the sub plots, define the fixed size equal, I put here its fixed size is 10 comma 10, okay? And I want to display GDF overlay. Okay, and I will just put here the dot boundary dot plot plot function. Okay, and I want to create ax equal ax comma, and if I just run the code, so then it will be display. Okay, you can see create this type of plot. Okay, we create some plot. Okay, we put the range for the x-axis 25 and also y-axis 12, and we just create the intersection. So that's the reason we find out the plot only our boundary, within our boundary, not the outside of the boundary. Okay, so this is the way how we can easily create the plot, and why it need in your agriculture precision, because it's called the variable rate application map. So when you create the variable rate application map for your agricultural land, you need this type of block, or you need to create this type of cell for your boundary to identify different types of crop information, such as for each grid or each cell how much crop productivity. Okay, or by identifying area with the different level of productivity. Okay, and also soil fertility for each cell, I want to identify soil fertility, or topography, knowledge of topography of the land is essential for the planning or irrigation. So which cell I need the irrigation, which cell I need the high crop productivity, or which cell I find out the pest or diseases. So for the region, when you have a shapefile, suppose you have a land, you have a boundary of your land, so this land we simply create this type of cell. Okay, you can also increasing or decreasing the cell size, it also depend on your study area. So in this case, I put the 25 and 12, and I create this type of grid or cell. Okay, so I hope you also get the idea how to create the cell, okay, within your boundary. Yeah, any question?
Yes.
Okay.
Yeah.
Okay, so we create this type of boundary for the cell size, and after that, okay, just a minute. Okay, suppose now I want to create, suppose for each cell, suppose this cell, from every cell I want to compute the anything. Suppose I want to compute the vegetation, how much vegetation this type of cell, each cell, how much vegetation this type of cell. So for that, first of all, I need to create the vegetation map using this satellite imagery. Okay, then we can easily compute for every cell we can compute the vegetation percentage from our NDVI map. Okay, so if you want, you can also create the NDVI different way, or if you want, you can also extract the vegetation different way. Suppose you can also take this you can make the NDVI map anyway, you can different way you can easily extract the vegetation information. So now what is my target? So my target is that I want to extract the vegetation information for every cell. Suppose this cell, how much vegetation, percentage, this cell, how much vegetation, this cell, how much vegetation, this cell, how much vegetation, we can compute. So let's go how we can easily compute this type of things. Okay, so here we already upload our satellite imagery. So if you want, you can also create the NDVI, okay, different way. Or if you want, you can also apply the threshold technique to identify NDVI, okay. Okay, so let's go. I'll try to discuss all of those, how we can easily get. Okay, so first of all, okay, so this is my image. So just I take the new cell after the image. So now suppose I want to create a variable R. So this variable I want to extract the band of red band. Okay, so for that just call the img, because this variable is stored your image img, and you can see what is my shape of my image. So this is the height, then width, and this portion we need to set band information. Okay, this is the position. So this position, this is the height, this is the width, and this is the band position number. So for that I simply put the img, and I put, you can see I put here the first position, nothing, put the comma sign. Second position, there is nothing. Third position is my band information. So for the red band is the 0, so I put the red band number 0. Then same process, take the green band, I simply call the img. So same process apply. First position nothing, put the only for the colon sign and comma. Second position nothing. Third position is the band position. So for the band position, for the green I put the 1. Same for the red, green and blue. So same process, take the equal sign, call the img, and first position there is no band because first position is the height. Second position is the white, also there is no position for the band. So band position is the third position is the band, so I put here the 2. Okay, so when you select the specific band from your composite, so this is the image composite. Okay, so suppose when you work with Landsat or Sentinel, so there are the lot of bands we find out. Okay, so same process you can also apply. Suppose after this session when you work, so you can simply download the Landsat or Sentinel imagery from your Google Earth engine. Okay, then simply upload this image on your using the raster. You try to read the image shape and also check how much band is available. Okay, further you try to separate the band using this way. So first position is for height, second position is for width, and third position is the band. So I simply put the 0, 1, 2, so band per number, and run it. So now it extracts the red band, green band and blue band. Okay, so image we find out this type of format. So red channel, all row and column, and band 0. So green channel, then blue channel we simply create. So now you have 3 separate band we create. And what is the format? 2D array. So if you simply take the new cell and print the R, suppose I print the R, so we find out the 2D array shape. It's called the 2D array. So for the R, for the G, same. Okay, we find out the 2D array for this type of band. So now we just handle the value in the green channel. Suppose I just simply work with the green channel. So this is my green channel. So replace all values equal to 255 with 0. Okay, so replace all value. If you check the green, we find out the all values, it show the 0 0 0 0 0 0 0 0. So this type of 0 value, I simply replace all values equal to 25, 255, 255. So basically, why I put the 255? 255 is usually maximum brightness value in 8-bit images. Okay, so 255 is usually maximum brightness value in 8-bit images. So it's a 8-bit image. So when I put the 255, it usually the maximum brightness value in the 8-bit images, and it's used to remove no data or saturation pixel of the green band. So now this type of 0 I simply replace with 255. So for that, take the new cell and take a variable, suppose g, and I call the numpy np. I just set a condition numpy where g, I set g equal 255 replace with 0, because we find out the 0, and I define the band name g. Okay, so when I apply this code, what happened? So it show the result, all of values for 0. So this type of 0 value automatically remove and replace 255, and 255 is usually use the maximum brightness, so 255 is maximum brightness. It provides the 255, this value provide the maximum brightness value in 8-bit images. Okay, so let's go try to replace and then check what happened. Just run the code. Okay, it's working. So there is no problem. So now if I just run the code g again, so just run the code. Okay, I think it replaced. Okay, so now we try to apply the threshold. Okay, suppose we're just applying the threshold value. So for the threshold, okay, let me try threshold. So take the new cell and take a variable, suppose fresh, and apply the threshold multi-outshoe. So it's one kind of function or library. We need to import the library in here. Okay, so let me import the library first, then try to use the function. So this library name is, so from, it's come from sk image dot filters, then import threshold multi outshoe. Okay, so now I already install it, okay, my environment GeoAI, so that's why I hope there is no problem. Okay, there is no problem. Okay, so now I can easily use the threshold multi outshoe. Okay, okay, just I apply threshold multi outshoe, this function. Okay, and call the g. So now this function threshold multi outshoe, that separate an image into classes based on the pixel intensity. Okay, and for the 8-bit images, it open give you the two threshold splitting into 3 classes, suppose low, medium, high. So this thresh will be something like T1 and T2. Suppose I create the two classes using the threshold. Okay, so compute the threshold with multi or shoe. And now we simply take only for the higher threshold. Okay, so for that, run it. Okay, there is no problem. So now we create the binary, the green band. So for that, take the new cell. So now we just simply take the greater than value, greater than 1. Okay, so for that, take a variable, suppose binary equal, call the g. From the g I just call the thresh. Okay, so from the thresh I just choose greater than 1. So put here the 1. Okay, greater than 1. So now this one, where g is greater than the higher threshold. Okay, and 0 is the false, 0 is no, so we take the higher threshold value. So for that I simply put the greater than 1 of the binary value. Okay, so this binary we need to convert into 8-bit. Okay, so for that, run the code. Okay, there is no problem. So now take the new cell and I want to put, suppose binary equal binary as type. I said the type, it's 8-bit, and 8-bit we define UNINT 8. Okay, so now further I want to display the image. Suppose I want to display the image. So for that, simply plot figure. I want to plot the figure, put the fixed size equal, I put suppose 14 and 10. This is my fixed size, and put the plt dot im show of binary. So now run the code. Okay, it show a problem. Matplotlib has no attribute. Okay, img show. Okay, what the, okay, img.
Sir,
Yeah, please.
okay. You are written IMG show.
Okay, im show. Okay, sorry, it im show, not img, im show. But
Yes.
so now let's check what happened. I hope it will be working. Or if not work, then we try to save this file in our local drive. After we can easily visualize again. Okay, suppose sometime when lot of analysis it crashed. Okay, then what we can do, we simply save the file, GOT file. So this binary file we simply save in our local drive, and from the local drive we can easily display again.
But it is working.
It's now working. Yeah. Okay, so it will restart automatically. Okay, let me save it. Okay, so now, okay, so it will restart. So now let me run again all of code. So for that, click on the run and run. Okay, so run. Okay, let me check. I want to save it and then display. So just I remove this line and then click on the run, and you can see the run all, run selected cell, run selected insert, run cell, run selected, run all above the cell. Okay, run all cell. So now all
Yes.
of cell will be automatically run again, and further we also write the code. Mainly we try to save the file, GOT file, and then further we can display or also work. Yeah. So last minute working. Yes, it working. Yeah. Okay, it's done. Okay, so now my target is that I want to save this binary image as a GOT file in my folder. Okay, so that's it's very easy for we can already display this, or we can also use it for other analysis. Okay, so for that, how I can save? Okay, so first of all, okay, so take the, suppose I want to put the binary and check the shape. It show the two shape. Okay, two shape. But in the rasterio, expect data in the format 3, suppose band, height and width. But in this time it show only for the height and width. Height and width. But when you work with rasterio basically it need the 3 format data or 3D array. It's called the 2D array. Okay, but rasterio expect the data in the format 3. So when you work with rasterio, we need the 3 format. Suppose first format bands, second format suppose height, third format suppose width. Okay, but in this time, this binary, this image only have 2D array. Okay, only have the height and weight. So now first of all, we need to add the another information for band. Okay, height and weight is already available. So now we try to add the new. So now binary has, we need to add the one new band. So for that, because I want to work with the rasterio and export. So for the, when you export, it's help you the rasterio. Okay, this function help you when you export this GeoTIFF file. Okay, for it's help you, and this rasterio always expect the data, it can be 3D, three information, suppose band, height and width. But in this case, my data, my binary data have only for the two information, height and width. So height and width. So now I need to convert. So how we can convert? So take the new cell. Suppose I take a variable binary equal, I call the binary, and I apply, call the np, basically numpy, and I create the new axis to create a new dimension, to add the new extra dimension, and I have already two dimension, height and width. So I just add the new dimension, okay, using the new axis help of numpy. So now it is a 3D array. So in the 3D array, because I need to export help of rasterio, and rasterio have the 3D dimension, band, height and width, okay, but binary have only two dimensions, so that I simply change the shape. Just run, and also now run. So now you can see we find out the 3D. So first is the one band, second height and width, okay, we can easily check the shape. We can simply convert the 3D. So now binary has a one band, so now we can simply okay, so now we can easily export. So for exporting, we need to add, copy the metadata from the source images, So for that, I simply take a variable, suppose out meta image. So I call the src source dot meta dot copy function. Okay, so here src.meta contains the metadata of the original raster, including coordinate system, including georeferencing, including driver file type, and also width, height, number of bands, data type. So src.meta, src, not cr, so src, src.meta. So this contains of the original raster, including CRS, transform, driver, width, height, bands of number and data type. So copying, ensuring we simply copy. So now run the code. Okay, there is no problem. So we can simply copy the metadata from source image. So now we try to update metadata for output. So we simply update this information and we can create the output. So let's go try to output. So just I put, suppose I just call the out meta image, just copy and paste and put the update. So now I define some argument, keyword and key value. So make a dictionary. So first one is for driver. Okay, so put here the driver. So define here the geotip or g tip. Okay, it's called the geotip, this format. And then height, define the height. So this height, it's come from binary, basically from binary, okay, from binary height, okay, 0 1 2, 0 1 2. So this is the 1, so height is the 1. So put here the 1, okay, and then comma sign and take the width. So define the width. So it's come from binary width. What is the width? Width is the 0 1 2, okay. width. Okay, sorry, binary shape. Okay, so from the shape we call the 2 basically height, and from the binary we call the shape of 2 is indicating about the width, okay, height and width. So height and width is simply defined. Then count basically how many file. So I want it only one file, I want to store it only one file, so put here the count and define one. So when I put the one, what happened is this file one time export in my folder. Okay, count. And then we also define the compress. Okay, compress. Okay, so I'll write the code. So it's called the compress. Compress. So compress, I choose LJW. So LJW, this compression in reduce the file size without data loss. Okay, so this function basically help you reduce the data size. Suppose your data set is very high, so it reduce the file size without data loss. Okay, it's help you, this compress function. And I compress WLZW. Use the LZW, it's help you reduce the file size without data loss. So this is the one, another benefit. Okay, so now define all of those and run and then check what happened. Just run it. We face a problem, I think some mistake for spelling. So SEIS, it show the problem. Binary shape, shape 1. Syntax error, if it's some problem for the syntax error. Why it show the error? So high, yeah. So we put the quotation here.
Yeah, no quotation there.
Yeah. So now run the code. Okay, so now there is no problem.
Yes.
So now after setting this type of information, we need to set the define the output path. Suppose where it will be stored, this file. Define the folder direction. Okay, so just I put the suppose path to save. So here I save it. So define the path. So user os dot, basically this is the one kind of Python package os. It help you to save the path. So put here the path and put the join. Okay, and define the path. So suppose I simply copy, suppose this file, I simply copy the path. I just paste here this path information, but I don't need this file. I create the new, suppose I put the name of the file. Suppose I put the name, suppose new vegetation, dot tip. I put this file name. So when it will save, we find out the new, this file name we can also find out in our this folder. This folder we find out. So now os, so this os Python package I need to import. So just I simply put here import os. Okay, so it will run. So now let's check what's the happen when I run the code. Okay, let me run. This one. Okay, just I save this path. Okay, so there is no problem. So it means that this file is successfully saved. So file will be saved, this file name. Okay, so new vegetation tip. So now simply you can see refresh button. So now let's check where the file. So you can see this is the file, new vegetation. Where is the new vegetation? Yeah, this one. No, I put the new vegetation.
Not yet saved.
Okay, just let me run the code. Okay, let me check. Suppose let me take new cell and I want to open it. Suppose I want to open with raster Rio, with Rio dot open part to save. Okay, so now, okay, sorry, we are it not save because we save it help of raster function. Okay, so now with Rio open part to save, and we define the writer mode. Okay, so we define the w means writer mode, comma sign, and then we simply define the output meta image, copy, and put here the double star and paste here. Okay, and then put here as I put the short form, suppose data. Okay, as data, and now data dot write, put here the binary. Okay, these are variable name binary, who is stored the data binary. So now run the code. So I hope now it will be saved. Okay, it's working, you can see. So now it's saving. Yes, okay, done. So now refresh. We find out, you can see new vegetation tip now. Okay, 36.8 megabyte this file. So now you can easily get this file. Okay, and further if you want, you can also display. Okay, same process now, or you can also open this file in the other geospatial software. So this is the way when you save your geotip file, just apply the same process. Any geotip file, when you save the tip file. Okay, so now our vegetation analysis is done. So we create the vegetation map, as well as we also create the cell. So now we compute the per cell, we compute the percentage of vegetation. Okay, so for the percent we calculate the vegetation. Okay, so let's go try to calculate the and also create the map for the parcel. Then you can easily get the idea which cell have the better vegetation. We can easily get this type of idea. Oh, so now take the new cell. Okay, I take the new cell after the cell. Okay, it's great. Okay, so now we try to create some block. So this type of block, and this block is doing the zonal analysis, calculating the vegetation area from your binary. We already create the vegetation binary. So now we prepared the, first of all, we prepared the empty list. Suppose I take a variable, I put the variable name is the area list, and make the empty, and also take the another variable was percentage this, and put the empty. Okay, so I create the two empty list. So this empty list, suppose this variable, it stored the information absolute vegetation area for each polygon. Suppose each polygon, what the vegetation area it computed, and percentage, it stored the percentage of vegetation relative to the polygon area. Okay, so run it. So after that we simply open the vegetation marks raster. Okay, so this is my vegetation marks I already created, new vegetation tip. So take a variable, suppose src, and I just open. So put here the raster rio, so rio, because I put the name is the rio. I want to open it, so open, and then copy this path and paste here. Okay, so now if I just run the code, it work, there is no problem. Suppose I want to check the shape, so src dot shape. Okay, we try to, okay, so we try to use the for the shape, we need to use the another suppose. So it will store it, the information here, src. Okay, so now you open your binary raster marks this variable. Basically we find out that suppose I put the src dot res. Okay, oh sorry, src dot shape. So you find out this type of shape, and then if I check suppose src dot res, so now we find out the pixel width and height, or resolution we find out from here. Okay, this is the pixel width and this is the pixel height. Okay, so now we create the loop through the polygon. Okay, we create the loop through the polygon. So let's we try to create the, so create the loop through the polygon. So for that, create a loop. For the loop we use the for function. For fit, I take the variable fit in. So now we need to load the JSON. So this is another Python library. So JSON convert the GeoJSON data format. Okay, suppose when you work with the GeoJSON format, we need to need this library. So it's called the JSON. So simply import it. So just put here import JSON. Okay, JSON library. Okay, so now we can easily work with the JSON library. So just type for fit in JSON dot loads, and now we create the geodata frame to polygon spilled by your grid, and then we apply a function. So just I simply call the overlay. You can see I already make the overlay. Okay, this is stored in a variable gdf overlay. Just I copy and then loads, and I want to convert into JSON. So for that, to JSON this function, to JSON function. So it's this function convert into GeoJSON format. And feature, we take the feature, it is take the list feature is polygon. Okay, so we simply define the features. So basically this features extract the list of feature is polygon. Okay, and loop goes through the is polygon geometry. Okay, so every geometry it create the feature. So now run the code. So if it's a problem, what's the problem? Okay, we need to apply here. Okay, so we create the loop. So for the loop we use at the clone sign. So loop, okay, incomplete. Okay, it also incomplete because we add some other function also. So let's go try to apply. So now marks raster by polygon. So for that I take a variable, suppose out. I take a variable out img, and out transform equal put at the marks function marks, and define the dataset equal src. Okay, src comma, and put the shapes equal fit with geometry, and I want to crop. So just put here the crop equal to true. Okay. So now what happened? So first of all, max, we are just using the max from the raster. So basically this function, max function, it's come from raster, and take the polygon geometry and crop the raster with that polygon. Okay. So now, okay, run the code. And max is not defined. We need to define the max. So now we just take the variable, suppose valid values equal this out image and we define the out image not equal, so not equal 255. Okay, so basically remove no data pixel which are encoded as 255. Okay, so just we remove no data pixel which are encoded as 255, and labels only 0 second, non-vegetation, and 1 is vegetation. Okay, and after computation area, so we just simply take the another variable, so we compute the area. So for that I put the variable name, suppose area. Suppose area I put for here, you can put any name or any, then I just simply call the valid values. I want to compute the total valid values dot sum, and these things multiply with our resolution. Okay, so for that call the src and for the res. Okay, and take the 0. Okay, basically it's find out that okay, from this value, with this value, it's a pixel size. So this is the 0 and this is the 1. So just I simply multiply also src and call the res resolution and take the 1 mainly this value 0.002, this value. Okay, so now we define the valid values, count how many pixel. Okay, so valid values sum, its count how many pixel equal to 1 vegetation, and multiply by pixel area. Suppose this is the pixel area, multiply by pixel area. So now result will be vegetation area square meter. Okay, square meter, we find out the result in square meter. So now we just simply after creating this area, so now we call this area list. Area list dot append with area folder, just copy and paste here. Okay, so now after doing these things, now we just compute the total polygon area. Okay, total polygon area. So for that, take a variable, suppose area total equal, just use the len function. Len basically number of all valid pixel. Okay, both vegetation and non-vegetation. Okay, just put the len and call the valid values, and then it's multiply with our area. So area basically pixel area. So how I can compute the pixel area? SRC, then call the res, take the first value for 0, okay, first value, and it also multiply with src, call the res resolution, and put the 1, okay. So now it calculates the total area, and now after calculating the total area, we calculate the vegetation percentage. Okay, so for the percentage, what we can do? So for the percentage, just call the area foliar. So these things multiply with 100 divided by total area or area total. Okay. So now it compute the percentage we find out. And if you want, you can simply connect. So these things simply connect with our percent this another empty function percentage vegetation. Just like copy, and for connecting use the append function. Suppose just put here the dot append with percentage. Okay, so now I need to print. Suppose just I print percentage. So now let's check what happened. Oh my god, marks is not defined. Okay, so marks. So we need to also import the marks. Okay. So let's go. Simply put here import rasterio dot marks, then import marks. Also it's from. Okay, so now I find out. Yeah, so now you can see we find out this type of percentage of vegetation for each cell. Okay, each cell, basically each block we find out. Okay, but it's not the better way to represent the percentage of vegetation. So further we create a map, okay, and display it. So for that we simply display. So just I take a variable. Suppose I put the variable name is gdf over gdf overlay. Okay, so gdf overlay. From this overlay I just call the area percentage. Okay, so gdf overlay, I put here it's a area percentage. Let me check. Or percentage, we put gdf overlay. We create any name, no problem. Then equal, so we call the percentage where you store the all of percentage. Okay, percentage list. If you check this one, and store it. And then another one, GDF overlay. I put, suppose it's a area meter square equal, simply call the area list. So we already make the area list. And define. So now use the underscore. What's the problem? Oh, okay. So now it is stored in here, and then we obtain the vegetation percentage map indicating the cell more or no or less vegetation. You can easily get the idea from here. So for that, simply take a figure. So put here the FIG figure, and also AX equal. So I call the PLT, create the subplot, and define the fixed size. I put the fixed size, suppose 20. Okay, and then I just create the layer. So I put the GDF overlay, plot area percentage, and put the AX equal AX. Okay, so now check what happened just on the code. It's a problem, area percentage invalid. Press you forget to comma. So we find out this type of map, but we can also represent it the more better. Add the legend or also title. Then we can get that each cell. We can compute the vegetation percentage map from the each cell. Okay. So let's go try to add the more information about that. Suppose I want to add here the color. CMap equal. I define the color. Suppose I put the color is that magma, or it's one kind of color format. And I put the, you can also increase the line width. So put here the line width equal 0.5. Okay, and then you can also define the S color. S color. You can put any color. Suppose S color I can define as a yellow color. Okay, and also add the legend. So put add the legend equal true. So now to add the legend. So now I'm okay. So now we find out this type of plot you can see, and you also added the legend. So you can see this type of color indicating about the high vegetation percentage area. So if you check this type of plot or this type of land, we find out the high vegetation or good vegetation for this type of crop. Or you can see for the this type of color indicating about the less vegetation percentage area. So this is the one kind of example, but we can use the different types of example, and it very useful for our agriculture precision area. Okay, we can easily identify different types of information. So just I show you only for the one for the your vegetation percentage area, but this same process you can also apply for soil moisture, or same process you can also apply for anything. Okay, suppose you can create this type of grid or cell, and further from here, from this grid or cell, you can compute different types of information. Suppose now from this map I can easily get the information which area have a better vegetation. Suppose you can see this type of land or this type of agricultural land, I find out the better vegetation. So that's why we can say that from this type of land we can easily get the high yield prediction area, or we can get the high yield from this type of land or this type of field. We can easily get that high land. So this is the way to work with your variable application rate map. We can also use this type of things and help of this type of grid.cell, help of GeoPandas or other this type of library. Okay, so now we can also try, suppose, and not only for the drone imagery, we can also apply it for the satellite imagery also. Okay, suppose we can simply draw a study area, any study area or any field area using Google Earth Engine or help of others, and then further we can compute the vegetation map. Okay, just simply extract the vegetation, and further you also try to compute vegetation percentage for the per area. Okay, so for creating the per area, you need to create this type of block or cell. Okay, I already discussed about that, how we can easily create the block or cell. So you also try to practice, okay, for any other data set, and I'll also send you this code, okay, and also send you all of data set. Then you also try to practice, okay. Then I hope you can easily get the idea how we can easily apply the variable rate application map. It's called the variable rate application. Okay, you can also apply the multispectral satellite imagery also, no problem. Okay, any question, please?
Oh, no questions, sir.
Yeah.
Now it seems that
So,
these
yeah,
these codes need to be very careful.
yes. And you just practice. Concept is very similar. I try to teach you very much easier way. I hope you can easily get the concept how it will work. Okay, so now you can simply practice for your own data set. Simply take the any satellite imagery, Landsat or Sentinel, further create the vegetation, and then further for your study area or for your shapefile create the block, and further from this type of block compute the vegetation percentage area or vegetation percentage, compute the
Yes.
vegetation percentage. Okay.
Yes, sir.
Okay, so you also try to practice these things, and it also help you to identify yield prediction also, because which have the better vegetation percentage we find out, it also help you to identify better vegetation or better yield. We can easily get this type of things from here, from this type of land or this type of breed. Okay, it provides the more better.
Okay, sir. Okay, sir.